So, stream is on. And oh, I'm having a small pause from the USB hubs, if you looked at the stream. And I'll do something which is a bit more, I don't know, a play thing. So previously on the stream, or on one of the other streams, it's been a while, I've used this power light. This is a DMX controlled power light. So I claim DMX. It's kind of the protocol is used in a lightning scene or in the event scene. And simply you just had to plug this and then you had a light. Let's show you. And then you have red, green, blue and white lights. And you can control them over DMX, or you have several modes. And I wanted to make this portable, so this is a really cheap one, and it's very cheap also because it's not through the DMX. It's not using the RS485 protocol. It's just looking at logic levels. And what I did is I converted it because it simply transforms the voltage input into 12 volts. And instead of that, I added a USB port and a voltage booster, so I can actually have the 12 volts. And this is can be now USB operated, and it means that it can also be battery operated, and it lasts a long while. And the idea behind that is to have a battery operated DMX light, or light which you can just throw somewhere. And this is very useful, so you can make some small events in remote places like parks and so on. So you go in a park and you just need a USB power bank and you can have some lights, and then the same thing can be done with audio, so you can have some dancing music and so on. So this is what I did, and I converted it. But actually there are professional products which are doing that, like this one, which is unnamed and which was given to me because it's apparently it's really shitty, at least in its usage. So this is also battery operated. It looks a bit more professional. It's very rugged. So this is metal, a metal box. Here we have a huge lights in the beginning, and then you can still see that it is not completely 100% professional and meant for the hobbyist, because DMX in and DMX out, so they are rugged and they are waterproof, but they are the 3-pin DMX. DMX is forbidding 3 pins officially. If you are really professional, then you have the 5-pin connector and not the 3-pin connector. So it's not meant for the real professional market, but more for the hobbyist market. And then you also have power input and power output. This is a weird connector for power output, but I think this is meant for providing power to speakers. And power input, I do have the cable. That's also a weird one. It's like this form. This is also what you very often find on speakers, but I don't know this 3-pin wiring thing. So it's a bit weird, and I don't know why they use this connector. Maybe to make it proprietary, maybe to make it waterproof. I don't really know. But for an AC input, and it's just AC, so it just means input. Nothing more behind that. And yeah, we have power output. I don't know what the power output actually is. Nothing is written on there. And you kind of see that it is not completely professional because there is no branding on this thing. There's no model number and so on. But it looks fairly solid. And one of the things which was said, so here there's a battery inside. We'll have a look at what the battery is, and if it says there's as much battery as it is, but we'll have a look at it. And how do I switch it on actually? And yeah, I played a tiny bit with it on site, and it's really not friendly to use. Okay, here this is a touch interface, and we have an OLED screen, I think. There is a screen, and it is as bright. If you leave pressed here, it shows the battery status, and then if you continue pressing, it says power on. So it's really not very useful. See, to go from left to right, you press up and down, and not like this left right. But it gets even more funny. If you want to choose a color, like you have to use static mode, and then you set the red, green, blue value, and here you go up and down to change the value, and not left and right. And then to change which of the colors, you go left and right. You use these two buttons, this button here. Not very useful. And so here we have some lights coming out, so this works. And who knows, so I'm an IT guy, I know what RGB stands for. It's red, green, blue, and then, but I don't know what all the things are. RGB, yeah, red, green, blue. V is white, A, amber, P, power, I don't know. And it's the value from 100 to 255, so it's a byte value. If you may do it for users, do it in percentage and not in byte values. So static color. So let's try to look what this amber is. Is this a value? So let's switch off. Let's switch off the white and switch on the A. A is blue, or is A kind of is the same as blue? Static color. Oh no, it's because blue is on, sorry. Blue. What is A? Address maybe? Oh no, it's amber. Yeah, A is really amber. So there is one more light. So up, let's switch off amber. P is probably purple. And purple is, they probably meant UV for purple. They, at least they say it is purple and not real UV, because real UV under 400 nanometers is something, no, P is something else. No, it is. This is purple. So it's kind of UV. It's not really UV, but it's going to, it's violet, purple violet. And also, so there is a remote which is provided with it, and they even failed to do that. For example, the exposure is far too high. Is one remote, this remote, okay, this is working, but not very well. See, if I press B, it gets blue, and it doesn't always work. I don't know why this reception doesn't work. Maybe let's try this one. Ah, here they call it UV, they don't call it purple. Ah, consistency, huh? This one doesn't work. Does it have a battery? It has a battery, but it's the wrong way around, so it can't work. Up. And maybe it's not even, maybe the battery is dead now because it's been the wrong way around. That's possible. Let's check the voltage of the battery. Up, you should see the volt. Up. Should be 3 volts. Is it 3 volts? It is 3 volts, so the battery is fine. And although the battery is fine, this thing does not work. So I don't know what the... Ah, now it's... Oh, you have to be super close to it. And sometimes it works. Ah, I see a hint of red, green and blue when the white light is on. Are they cheating? It's not usable. Okay, on. Red. See, I press on red and the color is blue. And what is this key for? Who knows? On. It doesn't remember the color. See, I pressed on green, it's still blue. it's crap. So yeah, the usage of that is completely crap, and the idea I had is to maybe, let's try to switch it off. Is it the same way? Yeah. Is maybe to change the software. And so we still keep the hardware because it is not that expensive. I think it's around, I would know. So I would say just bullshit. So keep the hardware, but let's see if we can actually have a look at the software and maybe change it. So we'll take this apart. So let's remove these things first. Up. There were ring in between. I think they are in between. Oh, they're ring in between and they're ring outside. Okay, there's one ring in between. Okay, it's in between and outside. So don't lose the rings, the plastic rings. Up. Now let's take apart the back. Screwdriver and bit set. Where is my bit set? Maybe it's in my small. Bit set is enough. Let's have a look. No. This one. Yes, this one works. Let's do it by hand now. Oh, there are too many screws. Let's maybe not do it by hand. So, like always, we will mark where the screws are from. That was my screwdriver. Sorry for the loud noise. Pen for this thing here. Back cover. Back cover. Wrong way around, this way. I find this multi-tool is really powerful, no doubt, but it is really too loud. I have another one which is a lot less powerful, but it doesn't destroy my ears. Up. This trusty thing, I've had it on the stream a couple of times. This is a very cheap IKEA screwdriver. Primitive, simple, but does the job and it's not loud. Are the screws all the same? Yeah. They are. Not powerful, not meant for drilling, but for screwing and unscrewing, it's perfectly fine. Okay, this screw is a bit too tight. Oh yeah, it is very tight. And there is a fuse also. I wonder if they just added that 10 ampere fuse. Just to be sure. Let's have a look at the fuse. See if it's a generic fuse or if they know what they're doing. Where is... Here it is. This thing, the proper tool. I think it is a fuse. Should have some marking on the outside to tell the fuse, and actually to tell the rating. That would be nice. Tell it's a fuse, and if it is a fuse, and it's no. This is something else. Everything is turning. Okay, I don't know what it is, because I'm turning the whole thing. Maybe it is meant to be turned. Yeah. Okay, it is meant to be turned. Okay, it's not... Ah! It's not a fuse. It's a water... kind of a water seal. See, there's a gasket, and inside... it's hard to see. There is kind of a diaphragm. Maybe it's to keep the moisture out. This is... I don't know. Never had a look at it. But maybe it is so it can... Yeah. So the moisture can go out but not back in case there is moisture. Or the heat. No, the heat, no. Because this is all aluminium zinc, so this is the heat. Ooh. It's not that bad inside. It's not what I expected. But it does work. So everything. No, the job is well done. Here they've added on the connectors, they've added glue on the side. Here too. We have plenty of different things in there. This is weird. But it's not, so can I unplug things easily? Okay, so this is kind of bad. Battery, okay. I would have added ferrules on these connectors. This is the battery voltage, this is voltage input. Oh, okay. Power out is actually is really AC coming out. It's not from the battery. This is a shame. I would have loved that this thing actually can be used as power bank, so you can connect other things. But actually, it is really just the AC which is forwarded, so you can chain them. It's okay. Also, yeah, so you can charge all of them in a chain, and you can power also other devices. Okay. Not what I expected, but that's fine. It would be nice to extend it. So I also want to have a look at this thing. This is, so here we have the power converter. Oh, the quality is quite good. No, nothing to tell, nothing to say here. Let's make a mark on. So these are the same connector, and I don't want to mix them. So we will mark them with different colors, else they are, yeah. I don't have that many colors. Up, up, up. Okay. So this is DMX, and the DMX is really forwarded. So there are several ways to forward DMX. Here it is really a copy. There is no buffer, there is no retransmit, and so on. Let's mark DMX in black. This is black, okay. And this one is temperature sensor. I think this is infrared receiver. It goes up in front, so this is probably the infrared receiver. Let's mark it in red because it's infrared. Red. is black. I also wonder how they, now it's on the back. Okay, we'll have a look at lots of electronics. So here we have plenty of power thingies. I'm seeing something. I'll tell you afterwards once we have a look at the board. There are plenty of options. It seems to be kind of a generic board. This is pro power. I don't know what this module is on the bottom. So this port connects to this module. I don't know what it is. And this connects to the front. I don't know what this is either. This is kind of a audio control. Here we see it's written mic from microphone. So it may be also, it's maybe able to make some animation based on the audio level. So for the mic, so we will use silver for the mic. The silver is not working anymore. This pen is dry. Come on, silver. Is it dry or is it just... this pen seems to be dry. Let's see if the gold one is not dry. Gold is fine. So this is gold. And silver, let's try to rescue it. It does some kind of silverish. Okay, now it's coming out. It's not visible. I still have some blue. So let's use blue. Okay. So we can unconnect and then we know where they are, where they belong. This huge connector, I don't have to mark it, there's only one of them. I think this is to control the lights, but we'll have a look. And here, ground and V+. Oh, there's V+. Okay, I'll mark it. V+ is blue. Battery plus is red and ground is black. It's good it is black, but you never know what they do. This, I don't know. So there are two things here. There is one RF module. Here, this seems to be yet another RF module. I don't know why they have two RF modules. This is probably Wi-Fi and this is probably Bluetooth, or I don't know. So see inside here, no markings at all about here on the board. Also, no markings who the manufacturer is. This is also a weird. This is a very weird and bad hack. So here, this is DMX. Okay, it's not what DMX. Here it says it's DMX. But this connector was DMX. I don't know what this is. I have an idea. We'll explore it afterwards. And we have one antenna. Why do we have two antennas? Okay. And this is white, so let's mark the black antenna black. Here, this is black, and we have the white antenna on here. Let's mark it white. Let's get a white pen. Oh, I have a viewer. You're welcome, Antoine. So here we have a white pen, and let's mark this one white to know that this is this one. So let's disconnect this UFL connector. I think it's called UFL, micro FL. And this goes in the front. This backs it, this makes it go in the front. This is here. So there's a PCB trace and there is this connector. And I think when you plug this connector and unconnects the PCB trace, at least I know there are some connectors which do that. I don't know if this one does it. Or if the PCB trace, no, it's meant, okay. It's done using using resistors. They are teeny tiny. Let me show you. You see on this board, they are teeny tiny resistors. And these resistors define if this goes up to this one or if it goes to the PCB trace. And I think if there's no resistor, it goes to the UFL, micro FL connector. Let's unscrew this. And we'll have a look at all. So this is, I have to kind of pay attention because it's a huge battery. I don't know if the battery protection is in the battery for short circuit or if it's in there. So I will just tape the contacts. Some electrician's tape. Up. Up. And okay, might be too large, but one ground should be no problem. But so this was battery plus, and this is volt plus. So that, yeah, the battery protection is not on this connector because you don't have battery plus, battery minus, and then ground. You have a common ground. It means that the protection is of the battery is somewhere else. It's not on this board. Maybe this is the charging. Okay, now I get it. We'll have a look at it. And so because the battery protection is not there, I think this board also doesn't take care of charging. It's just uses it. Well, ground can be flying. Oh, we don't care about this one. So we are almost done with being able to unplug everything. Actually, we can unplug, yeah, at least I can move it around. Let's have a look at here inside. So this is fixed. I think we have to unscrew the front plates to have access. Oh, did they do it correctly? Yeah, it seems they did put some thoughts. Okay, this is weird. Okay, this is the connector. Let's have a look. We have access to the battery. Kind of, we have access to the screws. Let's see if my screwdriver goes there. No. Here. Okay. I don't know how they assembled this one. It's not possible that they put the cable afterwards. It's far too small. This is a pain to assemble, a pain to disassemble. One screw. And why? Sorry. Power outputs? Okay. That's power input. Okay, power output is kind of shrouded. Okay, so you don't have, but on power output you can almost put some metal piece and then get AC. So this is AC input, this is AC output. I was thinking on AC you generally want kind of child safety and so on, so you don't want exposed metal directly. Here we have, so it is in the connector, but we could have exposed metal, and this is meant for going out on the outside, so you don't know who's piercing or things like that. Don't know if I would have used this kind of connector for AC outputs. 48 volt, fine. AC, I don't know. It's meant for outdoors. Something could poke in there because this is not very strong plastic. I would have used this connector. I was just thinking about it. So this is the first screw. Let's on the second one up. Does the plate? No, I don't think the plate gets removed. Oh, this is, yeah, it must be an assembly nightmare. Still not? Okay, I think this screw is screwed. And it's turning, it's flapping. Yeah, I think this screw is flapping around and not screwing down anything. Okay. So I'll have, can I change it? I still want this thing to be out of the way. Okay. So this is the power transformer. This is a standard brick, which they can buy. Trafo. That's the screw for the trafo. This screw is screwed. Yeah, it doesn't turn, so the screwing on the plate. Here there's a nut. Here there probably doesn't seem to be a nut. Then I don't know how it would hold. Ah, maybe the nut is turning with it. Okay, so you have to do it from the front. Oh. This is in, up. This is the outputs, and this is quite beefy but standard power supply. Let's check what it does. 14.5 volts at 5.5 amperes. That's not bad. Strong one. 80 watt supply. I think with 80 watts you can charge the battery quite well. So that's this one. Let's remove this board. I think this is the charging board and the charging board. That's my guess. That's the wrong screwdriver. Let's get another screwdriver. Up. This, I think charging. I will call it charging because I think this is the charging board. CHG, like charge. Charging one. Two. I think there are four. No, there are only three of them. And here we have the, I'm probably pretty sure it's the charging board. So here we have the charging input. Up. Oh. There's one piece which just got loose. You stay there. That was my screwdriver. So let's have a look at this board. This is probably oh no, it's not. Is it? Ah, it's not completely. It is kind of the charging board and power protection board, but yeah, so This is a 12 volt battery, 12 volt Li-ion, and it uses Sony 18650 cells, which are just the standard cells. I think there are plenty of them. And it has, I don't know how it is advertised. I mean, I have no name about this product, so I can't tell you what they say, how much power it has or not. But at least this battery says it has 16 ampere hour. That's probably this MA, milliampere. They probably meant milliampere hours. But so you have several cells in parallel and series. Because you have 12 volts output, you have 3 in series and then plenty in parallel. Because you have 3 in series, you need to charge them differently. So you need some kind of balancing. But to do the balancing, you need to tap on the middle ones. Here we have only this from the battery, plus and minus. So this board doesn't balance anything. I think this is just the charging and power protection. You see here 3 beefy MOSFETs. I think they are here to cut the power if anything happens. And to switch actually, because we have, this is the power input from the transformer, this transformer, 14 volts. So this is the higher voltage. And I think this switches between, because you have 3 cables. Oh no, it doesn't have to switch. It is connected directly. Yeah, okay. This, so the plus, okay. This is weird. Okay, I don't know what this board is. I don't know what this board is, because here we have the battery connection. Plus, no, this is the charging. Okay, this is the charging. The charging goes directly to this connector. You see the plus and minus go directly on here. The blue cable, and the blue, I think it's V plus and then ground. So it doesn't protect the 14 volts are directly forwarded. But the battery, which is here, this is probably then controlled. And probably this is a charging circuit, because we have here an inductor, and it would make no sense to use an inductor if you only do switching on and off. We have these huge resistors are here for current sensing, to know if there is a short or not. And here we have an output. This probably tells if there's a fault, or if it is charging, or if it is charged. I don't know. We have some LEDs. I don't know what the LEDs are. It is connected to the battery, and still we have no lights. Probably to it only indicates the light if we have power coming in. We could test it. This is AC in. I just don't have to touch this thing. And we have this board, which is the output. Let's test what it does when you power it. Let's put it this way. And then we have the power cable. Where is the power cable? This is the power cable. Power out, power in. Power in. Will it complain? I think this is separate, so this is completely maybe. I don't know if this is a controller or an output. I would say it's an output, because there are 2 wires only. We'll have a look. If I put it here, yeah, it draws 10 watts, and then it says red. 40 watts. Okay, now it's drawing 40 watts. And the red probably means it is charging, and I don't know what the output here is when it is charging. Maybe it tells I am charging. No, it wouldn't tell I am charging because actually you probably want to know the battery. How do you measure the battery? We saw that this. We saw on the screen that it told us we have 72% battery. So it did probably measure the voltage. So it knows the battery state. So this is probably just to indicate if it is charging or not. Let's have a look at it. Up. I have 0 volts currently on there. And if we switch off, it's still 0 volts. So this is not an charging indication. It's probably a charged indication or fault. Could be either. Or it's a control signal. It's a control input. Probably not a control input. So this is a charging module. Okay. Let's disconnect mains. Up. And this is completely separate. It does get warm. This heatsink. I've never. Why? This a green heatsink? I don't know what green. Probably this is just coating. Wouldn't make too much sense to put some coating. I don't know what it is. So that's the charging. That's the battery. This is a 12 volt battery. There's no point in looking more into it. I want to look behind the plate if I can, because this screw, I have to change it. I can't use it anymore. Well, not sure if it's ever meant to be used. Was ever meant to be used. How do I remove the plate? Maybe this is on the side here. Screwdriver. That's probably not long enough. We'll have a look. Where is this? If it's not long enough, I still can cheat other ways. So this is probably to remove. Yeah. I can't go on this thing to unscrew it. Do I have a long one? Something long which can handle that. No. I do have. Just have nothing that's just that long. Does it mean I won't be able to have a look at the LEDs? No, I want to tear it down completely. Okay, it's not ideal, but it kind of works on the side. Okay, it doesn't work. I'm just breaking my screw bit. Oh, nothing which is that long. I want to have a look at it. Oh, here there are plenty of screws. Maybe something which is a bit more fine, which is precision tools. Yeah, probably the precision tool will work. Up, up. Okay, they do work. Okay, they don't work. The handle is slipping. That's not working, but we can use it this way. Okay, this needs some charging. So let's start this one and let's use the one which is really loud. I haven't used this thing and I've repaired it so often. I hope the charging circuit works. The LED is on, but I don't know if it does the charging. Do I have something to test if there's a charging? I do have one of these. Is it the right connector? One. Okay, it does some charging. 9 volts, 300 milliamps. And this says 9 volts, 300 milliamps. Yeah. And when it is unplugged, it's going up to 12 volts. It's only when it's plugged that it's going down to 9 volts, 300 milliamps. So it is actually a constant current driver. Let's use the one which is noisy. It does the job. Yep. Up. Oh. Put it in drill mode. Okay, it's tight in there. It's very tight. I'll switch off the audio for now because it's really loud. Up, muted. Is it? No, it's not muted yet. How do I mute? Okay, I'm back, and actually I couldn't turn any of these screws. They are very, very tight in there. I'm wondering why they're so tight in here, but not on the other one. Maybe for the heat sinking effect. At least it doesn't work with this device. Let's see if we can do it by hand. I think if it's not turning, it's probably not meant to be turned. Oh wow, this is super strongly glued together. No, I'm distorting the bar now, not the screw on the back. No, I'm not getting this removed. No, I'm not. So I can't have a look at the front. But what we have is this cable. I think we have the colors red, green, blue, white. Yellow is probably the amber, and then we have this gray, which is probably purple, and we have 4 grounds to share the load. And then we have 2 of these sensors. This sensor, this is maybe a temperature sensor. Let's see if we can measure a resistance inside. If there's a resistance, like it could be a 10K PTC or NTC. Let's check the resistance. If it's a temperature sensor to know if it's getting too warm or not. Could be 48k kilo ohm. Yep, it's probably a temperature sensor. I don't know what would have such a, and it's constant also. You saw it didn't change, the value didn't change. Say 48k, and it doesn't change. If it's a capacitor, it would be charging if it would go lower. So it's probably a temperature temperature sensor. And I won't be able to have a look at the inside, but I want to, because here is the antenna which goes. So the two antennas will have a look. I want to have a look in you. And I want to fix this screw. Let's try it another way. Let's see if I can put some strength this way. No, I can't turn it at all. Maybe so the nut may not be tight on the other end. I'm not able to hold it, to put pressure well enough so I can. No, this screw stays there. It's not meant for turning. So here we have, do we see something in the front? There's a hole for the LED, but this seems to be metal on the front. And if it would be metal, then I don't know where they would hide the antenna, this antenna. Okay, let's have a look at the other board. Let's discharge. If there's a charge, let's discharge the capacitor. No. Yeah, the power supply looks decent. Here we have a fuse, 3 amp. Up here we have an. Let's just disconnect this. So the earth is tied there, screwed, which is quite good. Here we have a fuse, 3 amperes. Then we have a class Y capacitor, common mode choke, MOVs, I think these are MOVs. Then we have the full bridge rectifier. This is probably a bleeding resistor, the huge one on the back. Capacitor, this is the MOSFET switching for the power supply. We also have feedback optocoupler here. We have also a class Y capacitor between the output and the input to suppress some noise, and huge transformer. And on the outputs we also have, oh, you can actually adjust the voltage. Here you have a small wheel. On this one you could adjust the voltage. And here we have an output, but why does it have 2 transistors? I would only expect 1. Maybe there's one which modulates the input and one which modulates the output. I've never designed a switch mode power supply. I just looked at them. So this is the power supply. We don't care. The charging board, we keep it as it is. And if it's good, if we have to change the code, then we don't have to take care of the charging because this is done completely separately. Now, this is the board I want to remove it. Let's get the board out of its box. Up. That's for later. That I don't use anymore. Screwdriver, it's this one, and this is motherboard MB. I used the wrong pen. I used a permanent pen, but nothing is always permanent. Let's just use some alcohol to remove this marking. Up. And let's call this MB like mainboard or motherboard. Oh, it is. Okay, I think. Okay, let's have a look afterwards. One after another. Let's first have a look. No, I'll first want to have a look at the other one. At the radio board. I think it's clever what they did. And it's an advanced feature. Okay. So here we have the screen. This is and the capacitive touchers. Well, quality is really, the quality is good. Nothing to complain about the build quality. Just the software, which is really, really shitty. But I first want to have a look at this one. This board is probably an afterthought, and I think so. Here it's written also DMX. Oh, here it's written IR. Okay. Let's zoom a tiny bit because you want to see more about the board itself. So it's written DMX and it was connected to the DMX, and I think it has there's a button. This is probably an evaluation board or something like that. I don't really know, but it is probably DMX because you see there's ground plus 5 volts, so to power the device, and then AB. AB are most often the name which is used in RS485, which is the electrical protocol behind DMX. So it gets DMX inside, and I think what it does is it is connected. So this is connected to the black antenna, which is on the front, and this microcontroller, which is an N51822. This is probably an NRF chip. And 51822. Up. We don't need the bookmark. Show bookmark. And 51822. Very probably an RF chip. Bluetooth low energy, and yeah, Bluetooth low energy and 2.4 gigahertz. What I think it does is it takes DMX in and it then sends it to all others. So you probably can have a master which gets DMX and then which forwards the DMX over the air to all other lights. I can't check because I don't know the brand of this light, but I think this is what it does. So there is, and curiously the antenna goes on the front of the light where the infrared receiver also is. This is probably DMX. So it is kind of really hackish because they didn't put it in the main board. It's like an afterthought. But also look at this. This HX or PX connector here, they only use one pin. They still use a 2-pin connector, but there's only one cable. And this is not meant for this hole. So you put everything, not just that. There's probably a signal they wanted. I don't know what for. 1, 2, 3. So there's one signal more they needed. Probably, I know. Transmit or receive. So it can either transmit over RF or receive it. And this is probably to control this module. I want to have a look at this module. It's probably a standard module. It's the DMX module, and it forwards over the air using 2.4 gigahertz. I don't think it's using Bluetooth. I think it's using just a proprietary 2.4 gigahertz because Bluetooth is kind of slow, although it's very reliable. But in DMX, I think it's 1 megabits per second. I don't remember. Okay. So there are no markings on this board, so it's maybe not a standard board. I don't know this brand, 3Peak. I've never heard of it. What is this part number? It's 3Peak 75176. Let me show you. I meant this part. It will make focus. 3Peak. I don't know this brand. N is very often for NRF, so this is just the transmitter. And yeah, I think the last pin is connected. Let's have a look at this. Three peak 75176E. Is it okay? Yep, it is what I thought it was. It is just 3Peak IC, no private connection, so it doesn't have an HTTPS. I don't know what site this is, but it is simply an RS485 because you need this. This is the electrical protocol used for DMX, and if I get this right, this pin, this additional cable is probably one of these pins: read enable and drive enable. I think read enable is always on, and I think it will be connected to the drive enable. And the drive enable tells that I can send some data. And if we now test the connectivity between this pin and pin 3, let's get in the beep mode. Beep beep. Let's between this pin and pin 3. If it beeps, this is what it doesn't beep. Okay. So it's not that. I would have. My guess was really that this would be the way so they can either read or send data, but maybe it does it automatically, and this is something else. At least it's not connected directly, so this pin is not connected directly on one of these pins of this RS485 transceiver. Work? Yeah, it does work. It does something more, but it's weird also that it didn't put any label on this. No, it's not one of these. Maybe it's going through a resistor. This is why I don't have it. Dun, dun, dun. No. Oh, okay. I still think this is to either transmit or read one way or another. So that's the DMX board, these are 2 screws, which was getting here. And it has a separate antenna, which is the black antenna, which goes in the front. And here, and I don't know where they put the antenna, but probably this makes a really poor, I can't open it. It's really glued shut. These things are glued. But on the front, we have metal almost everywhere. Where is the antenna? Is it just behind one of these lenses? So we can still have some output. I'm not sure if it's really that powerful. I can't test because I can't open it. And actually, because the battery is on, I don't want it. Let's disconnect the battery. Don't want it to short to something. because the battery is connected here. We could actually also tap to the battery and add some additional circuit for charging. So we need another connector. I don't know if there are USB-C waterproof connectors. There probably are, but I don't know of them. And we have the second antenna. This is also a 2.4 gigahertz antenna. I know. Let's get up. This is a 2.4 megahertz antenna, 2.4 gigahertz, and this is probably for your Wi-Fi. So this uses some kind. This one uses maybe some proprietary protocol. If I would implement it, I wouldn't use any ANT or any complicated thing. It's only DMX. You're only streaming bytes. So I would just send raw bytes over 2.4 gigahertz, then have the other one sync to it. We could have a look at the menu once we power this up. So let's have a look at the main board now. And we can zoom. This is the main board. It gets the power and it seems that there are 14 volts LEDs and not 12 volt LEDs. And here we have, why do you use, so here you have the MOSFETs to drive the LEDs. 1, 2, 3. It's written also red, green, blue, white, amber, UV. So purple is actually meant for UV. I don't know it, so you can strobe better. I don't know why you would use inductors for such. So because you have inductor, you probably also need the flyback diode in case you switch off. And I don't know if the inductors are meant because it's high power light. You have lots of current. There is some inductor. I don't know what this inductor are for, but here it's the black is not ground. It's V+. So they're using N-channel MOSFET because they're cheaper and more effective. Here detect. It's marked voltage detect. This is marked voltage detect, and I think this was the one coming from this part. Is it gold? Yeah. V detect. So it's voltage detect. I don't know. Or battery detect. Don't know what it does. But because it's detect, it's an input and not an output. So this indicates if probably the battery is charged at this battery, which is connected here, is probably telling if the battery is charged or not. That would be my guess. And here you see dual footprint. You have a huge footprint for a huge transistor, but the transistors have become very powerful, and now you only have this tiny transistor, which probably can pass, I don't know, 2-3 amps or even more. And we have, so these are probably the drivers for the transistors. Yeah, they have transistor driver. Oh, this is rare to see, to have separate transistor drivers. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. Here we have RS. Oh, okay. So here we also have this RS485 receiver, so it can receive and transmit directly. It doesn't always use this. This is to there. I don't know exactly, but here is an RS485 transceiver. Here is, this is very probably, oh no, it's a diode. It's a MOSFET to switch on and off the battery. So it detects if the battery is there or not, and probably this one is to switch the battery on and off. This, why would you want to switch the battery on and off? So it can control the battery. Because if it's only battery operated, if you switch off, you kill yourself. And it's a P-channel, so it's very probably a P-channel MOSFET. You see it goes from BT+, so battery plus. And, okay, I get it. It disconnects the battery from this. Okay, I get what it does. when there is a voltage coming in, so V plus, it probably monitors and knows we have power from the mains. I am disconnecting myself from the battery because I don't want to drain the battery while it is charging, and because it makes the charging quite hard. With the lithium ion battery or lithium battery, you first charging using constant current and then constant voltage up to 4.2 volts. And if you are drawing any voltage for the LEDs, it's really hard for the charge controller to actually know what it is. And in here, in this battery, there is a charge controller. There is, can we feel it? There is a PCB inside which does the balancing. You do require balancing when you have multiple cells in series. So in here, there's a balance charger. Just need to provide 14 volts and it charges. And here the input, we have some protection. This is very probably a switching buck converter. So because here we have the transistor next to it and it's next to the power, and this powers everything with 3 volts or 5 volts, very probably 3.3 volts, because I don't see, no, 5 volts. We need 5 volts. There's 5 volt output here. So this provides 5 volts. We can measure it afterwards if we want to. And here we have this circuit has not been populated. All of these, I think, is probably the mic detection. Temp. This is, I was right. You see this connector, which I marked blue up, which was going to the LEDs on the front. I marked it blue. Blue, you see the writing on here? It says temp for temperature. So it monitors the temperature of the LEDs. And if it's getting too warm, it stops controlling it. And yep, so there's some kind of protection. And I think this circuit here is to do some beat detection, or at least some volume detection. We have the input microphone. This is probably an amplifier, very probably a microphone amplifier, an audio amplifier, which is then just adjusted precisely so you can, if the music is loud, it will probably generate a pulse. It could be an ADC, could be. And then everything is done in there. I wouldn't bother too much of an ADC. I would just amplify the microphone input, and if it's loud enough, and then you just pulse the lights or change the light. It's the easiest you could do. Then we have the main microcontroller, which is just an STM8, so it's an 8-bit microcontroller from ST S207. I don't know. It's just a microcontroller. I'm wondering though, this was connected to nothing. Here is the model UC369 main version 3, and here is the brand. It's UC. Okay, let's have a look if we find UC. Maybe it's not the one which made these lights, but maybe just the board. Maybe both of them. UC369 main. Let's see if it yields some results. UC369 main. Main like main motherboards. Battery spray, UC, DMX light. DMX light, eBay. 269 is the price always. Is it 269? UC269. Yeah, but it's not the brand name. Could be something else. Let's enforce UC269. There's nothing with UC269. DMX light, yeah. No, I don't know what this thing is. And no one is viewing to tell me what it is. If I could have this viewer telling me what this is, I could probably have a look at it. There's even more which is not populated. Here we have a fan output. This connector is probably for the fan. Here we see fan V plus, so here we have a fan output. So it is quite modular. And here we have a radio chip, which is just there for the Wi-Fi, which is really shitty. We went to the website, so it acts as a Wi-Fi access point. It's really, really bad. It just doesn't work. It's not finished at all. 1, 2, 3. Here, mic. There is a mic. Here is a mic input. SGV. What is red? Red. Which one was connected to red? 3-pin. 3-pin. No, this is black. Where is the red 3-pin thingy? I did mark it, so it must exist somewhere. I marked it red, so there is a connector somewhere. Yeah. No. That's not a microphone input. This is not a microphone input. This is this one. This is the how is it called? The infrared receiver. It's not microphone. 1, 2, 3, 3 to 1. I think, yeah, this is the DMX input. This is black. Yep. DMX input. Here it forwards to this module, so it can control or receive DMX also. I don't know. There is only one driver. There is only one of these, so they're connected. They're really connected all together. This is also connected to the chain, so whatever you're sending in here will be over the air sent through this thing. And this is probably just a receiver and not a transmitter. And this, I don't know. Yeah, this is used just as a receiver. You don't need anything else, do you? Let me check. No, you don't. This module. We could. They left the pin 1 marking, but they didn't leave all the other information. I have a couple of RF modules. This is Wi-Fi, that's for sure. And we could use the website I've published in the last project for reversing, but we could also just have a look at the standard RF devices. Like this one, which is an ESP8266. Could this one fit? It could. How many pins does an ESP82? It's probably if it is embedded because it doesn't have external flash. Let me check how many pins. 1, 2, 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it has the same pin count. And it has also a clock, it has an antenna, it very probably is an ESP8266. With internal EEPROM. It could also be one of the alternatives, which is an RTL. I have it somewhere because I did find it in cheaper, how are they called? Power switch, son of alternatives, like, yeah, this one. This is an alternative to an ESP8266. This is an RTL something, and it is very probably pin compatible, but it requires external flash. This one doesn't. We can have a look actually. If the clock pins are the same, it's very probably the same chip. So if it's this way and the clock pins, okay, they're not the same. Here we have the, you didn't see what I meant. So here we have pin 1 marking, pin 1 marking. The clock is here and the traces go to these pins. Here the clock is here and the trace go to these pins. So it's not an ESP8266 because it's very rare that you find it. I've never seen where you have a clock on 2 different pins. So it's something else. But, and is the weapon, I think, yeah, it is controlling. So here is the touch. The touch is done using their own controller. Let's have a look at the touch panel. What I was hoping is to put kind of a VLED on top of it. It won't happen. Too complex, too many lights. Up. So here are very probably touch controllers. Yeah, I think these are Synology. Or I don't know. I've seen this brand somewhere already. And because of their location, there are touch controllers. You also kind of see this mesh structure. I don't know if it's a must, but this is where you find thing battery plus. And this is just an OLED screen. I don't know which one. There are not too many of them. It's probably using I2C. This is an voltage regulator for the OLED, so it probably gets 5 volt in and just talks I2C. I would guess it's I2C. Could be SPI. EDUM. These are probably the buttons. Let's check. No, we don't see the trace. I think these go to these pins. So these are the 4 buttons. Touch buttons with their own touch IC. Because this 8-bit microcontroller doesn't have a touch interface. Oh, sorry. I wanted to check something else. Oh, they're very serious. Let me move a tiny bit the camera. They're very serious with this with their transistors. See, they even have cutouts between this side and the other side. Very probably for cool. Oh, these are under the coils, maybe for cooling. And I don't know. But they go directly to the pins, except blue, but it goes from front. So it goes through inductors. Why do you put inductors on LEDs? Is it to control the brightness, so you actually control the current? I'm not familiar with this technique. I would have to read up about it. But what we can do is still have, so we could reprogram. I wanted to check if there are deep reprogramming pins on this thing. We could try to simply reprogram. They are not, it's not too complicated. Here we have, these parts I also wanted to have a look. Are these MOSFET drivers? I would have driven them by just using the pins of the microcontroller. but maybe because of the high, I don't know why they use, so it's SQ991991S. Are these MOSFET drivers? Oh. Okay, this is much more clever than I thought. I just want the data sheet. Just give me the data sheet. Ah, here. And not in Chinese. Okay. It is kind of. Let me put to the other screen. Okay, these are available parts. Yes, Sequoia. SQ stands for Sequoia. Let me switch the screen. Screen. Wrong one. Full screen. This one. Still not in English, but there you see. These are LED drivers. And here you see here is the transistor, here is the coil, and I don't know if it controls. So here's the PVM. Is it current control? It has a PVM input and then it controls using current the LEDs, and this is why you have a coil. I want to have this in English. Is this text which is selectable? Yes, so let's try to translate PDF. Translate PDF. There was something online. This one I think I've used and it did work. Convert PDF, I don't care, I just want to translate now. Upload file. No, I can't show you. Let me just, I can use this link though. Copy link, drag and drop. Can drag and drop. Let me clean the screen. I'll be back. Okay, so now this is cleaned. Now I just empty trash. Now I can show you. Home, downloads, and this one. And it's using just Google Translate. Yeah, you see here, powered by Google Translate. And it's stuck. So many translate. I probably need this one. I need to so many scripts. Up. Let's translate again. Taxi. This is a taxi. Chimney. These are chimneys. Chinese. Yes, it is Chinese. So you did have the right one. Translating document. I don't want to convert it, I just want to download it. Download. Okay, universal high brightness offline LED driver. It's an LED driver. Input voltage 80 volts. Arrive. DC input 9 volts to 500 volts. Drive current from view. Yes, it drives. It is a current driver. Okay, that's nice. That's really nice. Under voltage, short circuit protection built in. Scope, LED stage. So you put a PWM input and then it calculates into a current. This is where here CS current sense, and here we have the current sense resistor. This senses how much current passes, and it drives the LEDs with current. We can actually test it if it's really. This is why we have a coil, so we can actually drive it with using current. That's nice. It's really nice. And so the hardware is quite good. We could change the software though. It wouldn't have Wi-Fi, but do we want Wi-Fi? Let's have a look. So let's start it and let's see if it complains. So there's no programming header on there, but this we could tap on the pins directly. I also don't see any test points on this board. How do they program it? Oh, here, using this one. Or was this connected to somewhere? Do I have somewhere a 4-pin connector? I would have marked it, I think. This is 3-pin. Okay, this is... but I wouldn't have put this kind of connector. But it seems to be this. There's no other connector. Again, the thing has been removed. So this is very probably programming connector, and we can check it. It's STM8 using a swim protocol. So let's have a look at the data sheet. STM8 S207. Up ST, I want your data sheet. Which one is it? It's S6. SB, S8, S6, 207, S6. Oh, it's the really low range. Yeah, I think, oh, this is why it looks also so crappy. But only 32K of flash and 6K of RAM. It's not a lot. Well, it doesn't need also a lot because you don't need any bootloader, things like that. Download data sheets. Let's move it here. That's the one. Let's look at the pinouts. Oh, actually, I could use my website. Let's have some advertisement for advertisement. ICID dot. Yeah, not the secret page. I want the official one. There is a secret platform. So this is where you can change. You can look for devices based on the pinout, and then you can find it. We want only ST, and the part name is this one, S7. So let's try to find something. No, it's at 6. Yes, it is S6. And we have a S66C, this one. So now it's loading the pinout. Yeah, when it's not used very often, the database is a bit slower. It's still a 2 GB parts database. Here we have the pinout. This one is probably very similar. S60C6 stack. Yep. And so we can check. Normally there's swim and reset. These are the 2 programming lines. Reset is pin 1. And then let's look for the swim. Swim is pin 38. And let's check if on pin 1 or pin 38 we have one of these programming connectors. Up. Which one is ground? So this is ground. This one is ground. This third one is ground. Is one of them pin? So this is pin 1 marker. This is pin 1. Pin 1. Yep. Ground pin 1. There's probably V bus, and then we have 38. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one is the programming pin, and it's this one. So this is the programming interface. So we could connect directly to it, and so this means that this is 5 volt or 3.3 volt. This is probably 5 volt capable. Let's have a look at the data sheets again. Data sheets. So 3 volt to 5 volt, and I think it's operated at 5 volts. We can have a look once we plug in. So this is the programming header. I'm really wondering why they added this shrouded, or why they placed this shrouded connector. It's a couple of cents. They could have skipped it. Also, because they skipped on here, they could have pogo pins just connecting here. Because maybe it's too hard for them for the pogo pins, because here they didn't populate this, they didn't populate this, so they have some options not to populate things. Why did they populate this connector? But man, who cares? This allows me to reprogram it, and it's like, and we can see the traces. You see this trace going here, so we have the PVM trace going to the different LED drivers. Let's try it out. Not using the battery, and let's see if it starts. It probably will start. How does it measure the current? There's probably a voltage divider to measure the voltage. Here is the voltage. This has at least one ADC, doesn't it? You are at 10-bit ADC. Yeah, it has one ADC with up to 16 channel, a 10-bit ADC, and I think it's using this 10-bit ADC to measure the temperature and to measure the battery voltage. Let's have some cables. I think it's these ones I require. The battery is 12 volts. I want to connect to the battery, and I want to check if it works also without the battery. Up V plus, this will be 14 volts, but I think anything above 6 volts will work because we have a buck converter right there. Up. Let's connect to the power supply. You should see, let me change the view, so you can probably see the view, this one, and you should bench. You should see how much current it draws. Let's start with 6 volts, but 500 milliamps. 500 milliamps should be fine. 6 volts, yes, and it is on. Power on. static color 0%. Oh, it's very, very sensitive. This normally there is glass or something like that. Now it has issues. This is not connected to Earth. Now it has issues detecting something. Let's move this one. Let's use a foil or kind of a plastic. Do we have a sheet of plastic or something like that to put in between? Because else these buttons won't work. This is too large. Piece of paper. I want a piece of paper where there's nothing confidential. Here. On this one there's nothing confidential. See? You need some kind of paper in between. Now it works. If I just... Oh, it does also kind of work when I touch it. But it works better this way. So, let's go back. No. This is the back button. The back button doesn't work. Yeah, it's hard to make. We could actually put the thing back. There's nothing interesting on this side. So let's switch it off and let's put it back in this case. Up. This is the frequency. I didn't look at the datasheet of this LED driver. Does it use the frequency to indicate the brightness, or does it use the duty cycle? That would be interesting to see. Ah, we didn't check what this what this is. Well, it's not an ESP, that's for sure. At least it's not an ESP8266. It could still be an ESP32. I think ESP32 doesn't come in this 8x 32 pin package. Does it? Let's have a look. Let's have a look at my data sheets. Data sheet. Oh, this one. Trace data sheet. ESP32 data sheets. What's your pinout? Pin definition? No, it's a lot more. It's 56 pins. Well, depending on the version, but we could try to. Let's try to figure it out. This is a QFN package. We'll test online the tool in real time. So you can see that my website is not faking, but I also don't have a lot of ICs. So let's have some paper. Up. And let's try to reverse it to know what this chip is. Up, 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 up. This is pin 1. We need this in continuity mode so I can check all the pins. Here we have the voltage input. Which one is ground? Ground should be also connected to this ground. No, it's not this one. It's also not this one. So this is not a capacitor. This is a capacitor, and maybe... Oh, it has a separate voltage? No. It must have the same ground. This works. Okay, this is ground. This pin here is ground. And this is probably VCC. Which one is VCC? There's a separate VCC input. Ah, here, we can check again. The hell? Okay, this is ground. Let's call this pin 1. 1, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2 is ground. 1 is probably VCC. No. None of them is this VCC. Does it have a separate one? So this is ground. Okay, that's for sure. This one is VCC. It's actually VIN. It probably has an internal third one, right? Yeah. VCC. Here we have 2 traces which seem to have 2 traces. This is data. Data. And these 2 are also data. This one is probably the antenna, and it's not used. Doesn't seem to be used. So we have 4 pins, probably using serial. This microcontroller is not very beefy, so it won't do a lot. So it probably just gets serial data from these pins, and then the 2 other ones are control lines. So these one could be data lines, these one could be control lines. But we have a VCC and okay, so we have ground and VCC. These are the 2 most important pins. How many pins do we have per side? I think it was 8. Is this a pin? I think it's just cell screen. 1, 2, 3. We have 8 pins per side. Well, at least on one side. I think it's on both sides. Yeah, 8 by 8. 8 by 8 pin. And the size is, let's measure the size of this chip. The battery, okay, the battery is not dead yet. 0. 5.2. 5, it's 5 by 5 millimeter. 5 by 5 millimeter, not meter, millimeter. Okay. Now let's try to figure out the pins. The clock pins are these 2 pins. 1, 2, 3, 4. This is pin 1. This will be pin 1. 3 and 4 are clock. 3, 4 is crystal. Crystal. Which ones are ground? The can is, and it's using 40 megahertz. So this is a clue. 40 megahertz clock. Pin 1 is ground. 1 is ground. Pin 8. Is it pin 8? Oh, actually it has more than 8 pins per side. Oh. Wait, is this a... Ah, this is just a trace I'm scratching. It's not a pin. Let's check on this side. No, it has only 8 pins. Yeah. Pin 1 is not ground. I was touching something else. Pin 8 is ground though. Ground, we have pin 8. And there must be one next to this one. There are not a lot of ground pins. I think it's all earth in the bottom. I think the center part has all the ground connections. The ground one was just some other thing. Yeah, I think the exposed pad is the ground pin. So VCC, we have, I know there's a capacitor. Here there's a capacitor. This is 8, 9. Pin VCC is on pin 9, that's for sure. It's also other pins. 7. 5, 6, 7. It's a 5, 6, and 7. 5, 6, 7. But I wouldn't bet on 7, on 6. 6, 1. I wouldn't. I think it's just tied to something. It might be 6 with question mark. And then there is capacitor also here. Yeah. VCC is this one, right? Yeah. And where does this trace go? This pin. 16. Pin 16. And I think the last one is this. One, I think it's pin 24. 24 maybe. There might be other ones, but I'm sure about these ones. So let's check if we have a QFN which matches that. Up. So full screen. Up. No, we'll keep this one. So reset. So see, now it's fast. we have a QFN package, QFN, with 32 or 33 pins. 32 or 33. Yeah. Part name must include I don't care. 8 is equal to ground and 9 is equal to power. Think 8 that, yeah, 8 is a ground. 7 also. Here we have some. And it's very probably this one. Yeah, I said pin 7 or pin 6. I said it's not very good. We can have a look at the clock. This one looks quite like VDD again here, although it doesn't have an exposed part. The prog, this one, prog IRF. It's not a PIC 16, that's for sure, because PIC doesn't make this thing and low energy. Let's check what this part is. Does it do Wi-Fi? RF transceivers, yes. This is where I found you. RF. NRF. Does it do Wi-Fi? No, it doesn't do Wi-Fi. It doesn't do Wi-Fi. What is this one? Oh, not this one. This one. Iron chip. I don't know where I get this one. Well, I don't know. I could know. So the site can be improved, but here the source model is EDA. So it's LCSC part. What is this part? It's a microcontroller. Iron chip. Let's have a look at this one just because I'm curious. Pretty sure it's not this one because we need RF. Iron chip. ALU Mac. Mac. So it does some Wi-Fi. What are the specifications? Can I have a look at the specifications? If I look at this chip. No, it doesn't tell us anything. And here, this is here. Let's have a look. MCU, DSP. No. Also, the clock is not correct. So our ICID doesn't have it in the database. Maybe it's this one. Here clock input. That's not the right clock. Here clock here. No. This is probably the clock input, and this is not the one we're using, so it's not this chip. So it's probably not in our database. So 9 power. Let's try just with 9 power. We have plenty of them. It's not one of the TCC. MCR, blah 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 blah. We have plenty of NRF. 16, so we know, how was it 16? 24. Let's have a look at the board again. And 5 equal power. STM, no, it's not one of them. Yeah, we could find. There are not a lot of RF chips which we can search it also this way. Wi-Fi. That's another way with RF transceiver modules here. RF transceiver modules. Frequency, we know it uses a 40 hertz, so it could be 120 or something like that. That's the frequency of the output, 2.4 gigahertz. There are plenty of 2.4 gigahertz. Let's not look for this. Let's look for the package. Package here, QFN, BQFN 32 with exposed pads. Yes. Apply 4 remaining. ESP32. It could be an ESP32. With embedded flash. But I'm surprised that this one only has ESP32. The C5 series. I'm not familiar with this microcontroller. Let's have a look at the pin. Oh, yes. No. This is... yep, the pin. Supply and pitch don't match. And here we have normally not the... crystal. Crystal. Positive, negative. It needs crystal here, so it's not an ESP32. Let's remove the Wi-Fi keywords. Just look for the package. We have 6. PCB trace. It only knows about this. Probably other packages. Package. No, but it's the only one which has 32. 32 is not dip. So 48 which are remaining. There are plenty of ESP32s, but we are not an ESP32. These are modules. No, I don't want any module. Can I change the protocol? ESP32C3. Come on. Maybe they cheated and it's not... This is not pin 1. And it is an ESP32. They wouldn't do that, would they? Put pin 1 on some other place? Not module, exposed path, VQFN, yes. But also it's just DigiKey. DigiKey doesn't have everything. And also not knockoffs. But it could really be something like this, so it's quite inexpensive. Datasheet, let's have a look at it again. Pinouts. No, it doesn't match. It's something else. Actually, it's not a clock signal. VDDA, that matches. No, here, this is something else. This is tied high. No, we found a MTDI. No, it's not this chip. It's not an SP32. That's not it. That's not it. That's not it. No. And our database also doesn't have it. Could be any kind of module. Let's have a look at Ali Wi-Fi module. Maybe it is an off-the-shelf module with 2, 6, 2, 4, 6, 7 pin. 7 pin. If it is Wi-Fi, it could be something else, but this thing provides Wi-Fi. Plenty of ESPs. No. I think it's just a clone or something like that. I don't know what kind of module it is. It's very probably connected over UART, so we could try to sniff what it sends over UART. I see 2 pins here, 2 pins here. But yeah, do I want to spend more time? No, I don't want. I could, if I really wanted to have this Wi-Fi work, but we don't need the Wi-Fi to work. What we could do is simply remove this module and place our own module. And then, for example, place an ESP32 or an ESP8266 with VLAN on it, and then just talk. How do we do this? If we have VLAN, it could talk. It could debug over serial. Yes, over serial we could get the configuration all the time, meaning we know how hard the LEDs are driven. One per so one is each color, and then yeah, that could be a hack. We could use this. So as RF, we would use an ESP8266. We would pin out so that it's pin compatible, and also that UART is interfaced here. And then over UART, we just grab the data as fast as we can. We don't really care. And then we drive the 1, 2, 3, 4, 5, 6 channels, and that's it. We could really do that, but then we don't have this nice interface. Which, do we require this nice interface? We could still program it. This is very probably an I2C or an SPI OLED driver. We just have to figure out which are the OLEDs, so we could also drive the screen, and we could really have a VLAN on there by changing this module, but we need to change the module. So that's a possibility, but for now I'm done with reversing. Let's try to fit everything back together. Here. Bench. I wanted to do this. Bench. Let's fit everything back together and see if it still works. So this goes here. Nope. This goes this way. Let's clean the screen. I smudged my fingers. Up. Main board. It's this one. So the quality, construction quality is quite good. So we really could write our own firmware. We have output here, and also it could. We don't have to. Yeah, it could be nice. We could read the DMX data. How does it configure? Yeah, we need some DMX configuration, so we need the touch screens. And then if there's DMX data, right, overrides the VLAN values. And it's actually a good thing. Yeah, that's how I would do it. I wouldn't want to try to reverse this. I would just put a module, just use an ESP8266 and put the module here and use TX and the serial to get the data out, and then write a very small firmware on this one just to control the lights, control the menu, so we can reset, so we can set the DMX. Yeah, we could design menus. It's not too complicated to design menus. So we would need to drive the LED, the OLED. Just have to figure out what is connected there. So the DMX board, it's this one. It was connected this way. Up. So the hardware is not bad. The because the software is bad. And we could write our own software. And changing this module is quite fast because it is on a pin slot. Also, this wouldn't remove, we could slot it so that we could still reuse the original one. What we can try before I close is reading out the chip to test if it is read protected. That would be nice. I need to go somewhere for 1 minute and then I'll be back. Yeah, I needed to get some water. I'm thirsty. So, let's try to remove that. I don't remember which was reset, which was swim, and so on. But let's try to read out the firmware and see if it is read protected. Mainboard. Up, tack, tack, up. Let's get a cable. This is one of these IDC cables. The problem, this is not in front of my screen. Let me make some space so I can show you. Also, the Wi-Fi didn't work, so yeah, we tried. There's no voltage now. Okay, so it is charged now. The Wi-Fi just didn't work on this chip. It couldn't do anything, so we don't lose any functionality if we don't have Wi-Fi. And VLAN could be nice to have. Okay, you have a permission error. I think USB has died. Yes, USB has died. Let me start again. Interface, USB is disconnected. All USB has died. Okay, I'm back. The complete USB stack just on my computer just crashed. But this time I didn't restart the core computer. I think USB now works again. Let me try. Yep. Yep. It works. So let me get the other camera so you can see what I am trying to do in front of my desktop, not on the bench. Camera, you are on. Switch camera. No, you did not switch the camera. Are you actually still working? No, you are not working. This thing kills me. Okay, now we have my computer camera. So you have the screen. Let's connect this. Which one was which one? I need a J-Link. Something like, no, I don't want to use this one. I want to use a fresh one. I have plenty of them. No. Oh, I need to make a video about this. Voodoo. No, it's not in this box. Here, dirty voodoo. It's this box. Up. Okay. So here we have an ST-Link. Let's use the multimeter to figure out. I don't remember which pin was what. And let's write it down this time. One, two, three, four. Check. Which one was ground? This is ground. Pin 3 is ground. 3 is ground. This is not VCC. So which one is pin 1? Pin 4 is reset, because this is pin 1. Then we have this. Pin 2 is swim. Pin 1 is probably, it's not VCC. It's maybe 5 volts, but it's not VCC. That's ground. That's 5 volts. Okay, there's something, there's someone LDO, because here it doesn't ring. This is for the, yeah. So this is probably 5 volts. what is this output? X. Ah. This is 5 volt tolerant, so we just put 5 volt and we'll just hope that it works fine. It's definitely a power pin. Pin 1 is VCC. We'll put 5 volt on it. So we have this connector, and this cable. Puck. And how do we connect on the other side? Do I want to crimp cables? I don't, but I will. Let's crimp these ends so I can use it. Crimp and Dupont case. Up. Up. Crimp. I need to crimp. 1, 2. 3. 4. Up. Okay, 1. 2. 3. 4. Let's put some 1, 2, 3, 4. That's 5, 6. The colors don't match now, but this is not completely fixed. If it would be fixed, I would change the colors really. Oh, we could. We could make it a fixed programmer. Not for now. So this in black, this is VCC. I will put it on 5 volts. Then the second one is pin 2 is swim. Swim is this pin. Pin 3 is ground. It's this pin. Pin 4 is reset. This pin. But before I actually use this device, I want to test. No, it's MCU. No, it's dev boards. Where are my dev boards here? I want to test the dongle and the ST-Link. It's been a while since I've used STM8. I would have to look at one of my projects to find out. So this is my box with plenty of microcontrollers, and in here I have an STM8. I did program STM8s already. So I have somewhere. This is not. Come on. STM32. Here. STM8. Don't I have one where I have headers which are soldered on? No, I don't. I probably used all of them. So we'll just use one of these. STM8, and we will use some probes. Probes and DuPont cables, female to female. They are not here. Maybe I don't need probes because I could use these, which don't need cable. I need one more. It's not the best one. I think all the other ones are good quality. Oh, actually I could use 1, 2, 3, 4, 5. This, yeah, could use this one. This is from the Best Pirate. So let's disconnect this, we will reconnect. Let's try if this still works. So we have reset, which is brown. Brown is reset. Tack. Then we have ground, which is orange. Orange will be ground. Up. Next one, swim, number 5. Number 5 is green. Green is swim. And then 3 to 3 volts, which is 7. 7 is purple. Purple, purple. Up. Now let's connect this over USB. Is it detected? Yes, ST-Link is detected. That's a good start. Full screen. I did have some commands. Let's have a look at how I did it. Explore. STM8S. We have a make file. Okay, that's the command I was using. That's correct. And we want to. What are the other options? CFFI programmer, memtype, read, print state, unlock. Yeah, we don't want to remove public port, list supported devices, memtypes, programmer, read, display help. I don't want to read, I just want to identify the time flash interaction has been performed, but it doesn't complain. Okay, that works. Was easier than expected. Let's check if let's check. Let's now we know it works. Let's connect with this. So again, one is VCC. We put 5 volts on it. We could use 3 to 3 volts, but we will put 5. Then pin number 2 is swim. swim is this one. Pin number 3 is ground, which is this one. Pin number 4 is reset, which is this one. So let's connect. Yep, it did start the microcontroller, and 5 volt is plenty enough. Can I show it to you? I need a USB extension cable. It's extension on extension. Not ideal, but I'll work with it. So you can see what I'm doing. So let's connect this USB up. Let's have it here. And if I plug it in, at least I have VCC and ground correct, because see, it switches on, so that works. Now let's read the light, power light. Let's see if it is read protected, and it's not up. I didn't check which one it supports. -L. We have an, where's the data sheet again? S207. Is the S207 supported? S206, 207, yes it is. 207 CB and so on. We have S207, which one was it? P6, something like that. Maybe it will find out. No valid part. Okay. Which one is it? S6. S6. Yes. Let's check actually if it's not power light head. Okay, it is read protected. I think when it's read protected, it just gives zeros, and this is what we see here. And this tool doesn't tell me if it's read protected or not. Maybe Swim doesn't allow you, but nah, I don't think that Swim doesn't allow you. Can I read the fuses or something like that with this tool? STM8 flash. STM8 flash doesn't have any. Yeah. This beep was unlock. Yes, you can unlock. I don't remember the Swim protocol. I think it allows you to check if it's read protected or not. Here we have zeros, so we are pretty sure it is kind of read protected. I have, does it support? Let's try this out. I have JTAG here. Was it this one? There's a version 11, I think already, but I have here version 10. Let's try if some more advanced software can do more. Did it detect? Let's switch back here. So it detected the J-Link. Did J-Link have a GUI? I think they did. Let's see, J-Link. View, GTP view. Wasn't there? I don't use J-Link very often. New firmware is available. Do you want to upgrade? Yeah. The new firmware. November 10. Waiting for new firmware to boot. Cannot connect to J-Link. Did you break my J-Link? Okay. So the new, this is not an official J-Link. I think, well, I didn't buy it on official channels, so yeah. It seems that the J-Link doesn't work on this hardware, the new firmware, but the old firmware works. But does J-Link support Swim actually? J-Link supported devices. Supported. Is there a list? I would normally click through the menus. Yes, we have ARM. Does it support Swim? This is what I wanted to know. ARM Legacy. No, it doesn't, does it? I think it's just for ARM devices. Swim. There are other tools. Okay, so I think the firmware. Let's just check. We did dump another firmware, the STM8. STM8.bin, there's probably firmware on that. Just to check if this works. No. Okay. There was no firmware on this one either. Maybe. So I don't know. I would have to really look again in my tooling and test if it can read or not. But yeah, the hardware is done. This is. We have a look at the hardware, and even if we cannot read it, we can overwrite it. Well, I'll have to try if we can read it. It could be nice to read it because this way, or we just desolder it. That's it. We could desolder, although we don't have new parts. We could desolder it and put a new one if we need a backup. They probably have all the same firmware, so once you dump it, done. And I don't expect STM8 to have a very strong read-write protection. But for now we cannot dump it. Let's try to read it again. Yeah, seems empty. Seems there's nothing in there. Yeah, I would have to test the tool. It's been a couple of years since I've used STM8. And I'm sure there's one or at least one tool. Do I use something else? No, I just use STM8 Flash, which is able to figure out if it's read protected or not. Or else I will just have to read the Swim protocol, which I have somewhere. But for now, that's actually it. So we have the look at this light. I will put it all back together, but not in front of the camera. It's just not too interesting. And let's see if we can make, if we will make custom firmware for it. There's not a lot to lose. So that's it. next time I'll probably do a USB hub. But for now, enjoy the rest of the day.